These 6 red dots are not supposed to exist. They're galaxies, each one containing billions of stars, and they appeared just 500 million years after the Big Bang. That's a cosmic blink. According to every model we have, the universe didn't have enough time to build anything this massive this fast. It's like finding a skyscraper in the ruins of ancient Babylon. The standard model of cosmology says this is impossible, and yet James Webb keeps seeing them. So either our telescopes are lying or everything we thought we knew about how the universe grew up is wrong. What did Webb actually find out there? For decades, we had a clean story. The Big Bang happened. Then came a dark age. No stars, no galaxies, just hydrogen fog cooling in an expanding void. Slowly, gravity started pulling matter together. Small clumps formed first. They merged into bigger clumps. Eventually, over billions of years, you got galaxies like the Milky Way. Think of it like building a sandcastle. You start with a few grains, then a small pile, then a tower. You can't skip steps. The physics doesn't allow it. This is called hierarchical formation. Small structures first, big ones later. And it worked. Every simulation confirmed it. Every observation supported it. Then in July 2022, James Webb's first deep field images came back. Astronomers expected to see tiny, faint baby galaxies in the early universe. Instead, they found monsters. Galaxies with the mass of our entire Milky Way, existing when the universe was barely 3% of its current age. The sandcastle was already a fortress. But here's where it gets strange. This wasn't just one weird galaxy, it was 6, and they weren't flukes. To understand why this breaks physics, you need to know how stars are born. Gas collapses under gravity, but gravity is slow, really slow. A single solar mass takes about 10 million years to collapse into a star. Now multiply that. To build a galaxy with 100 billion solar masses, you need generations of stars. Each one lives, dies, and seeds the next. It's a relay race across cosmic time. Our models say the first massive galaxies shouldn't appear until about 1 billion years after the Big Bang. Webb found them at 500 million years. That's like a baby running a marathon before learning to crawl. Here's the number that keeps physicists awake. These galaxies contain up to 100 billion solar masses of stars. In the time available, stars would have needed to form at nearly 100% efficiency. Normally, that number is around 10 to 20%. Most gas doesn't become stars. It gets blown away by radiation, heated by supernovae, scattered by magnetic fields. So how did these early galaxies convert almost everything into stars? We don't know. Which leads to the part that most people never hear about. This isn't just about galaxies forming too fast. It threatens the foundation of modern cosmology, the lambda CDM model. That's our standard model of the universe. Lambda represents dark energy. CDM stands for cold dark matter. Together, they explain how structures grow. Dark matter creates gravitational wells. Normal matter falls in. Stars form. Galaxies emerge. It's elegant. It's predictive. And these 6 galaxies might break it. If early galaxies are this massive, dark matter may behave differently than we thought. Maybe it's not cold. Maybe it clumps faster under certain conditions. Maybe there's a type of dark matter we haven't accounted for. Or, and this is the radical option, maybe dark matter isn't the full story. Some physicists are already whispering about modified gravity theories, ideas once considered fringe. Because when your observations contradict your model by a factor of 10, you don't just tweak the model, you question the model. We're talking about rewriting the rules for how the universe built itself. Every simulation, every prediction about cosmic evolution, all of it might need revision. So the real question is, does this change what we think is possible? Right now, teams across 3 continents are racing to solve this. Webb is still collecting data, deeper exposures, more spectra. Scientists need to confirm these galaxies aren't being tricked by dust. Ancient dust can make distant objects look more massive than they are. That's the conservative hope, measurement error. But early spectroscopic follow-ups suggest these masses are real. Meanwhile, theorists are running new simulations, testing exotic dark matter models, checking if primordial black holes could have seeded early galaxy growth. At the Space Telescope Science Institute in Baltimore, astronomers are scheduling Webb time specifically to chase these anomalies. At Cambridge, physicists are publishing papers weekly, sometimes daily, proposing fixes to lambda CDM. There's a deadline nobody talks about. Webb has a limited lifespan, maybe 20 years if we're lucky. Every observation counts. Every exposure is precious. And somewhere in that data might be the clue that tells us whether our model of the universe needs a small patch or a complete rebuild. Look at those 6 red dots again. They're not just anomalies on a sensor. They're time capsules from an era we thought we understood. Each one contains billions of stars that shouldn't have had time to exist. And now you know why that matters. The universe didn't wait for our permission. It built giants in the darkness while we were still writing our theories. Here's what I want to know from you. If Webb confirms these galaxies are real and our models are broken, do you think we'll fix cosmology within 10 years, or is this a century-long puzzle? Drop your answer below. Follow for more. We post every week.